Hi everyone, this is Praveen, Assistant Professor, Department of CEC365 Institute of Technology. So in this video, we are going to discuss about Unit 2, MAC and routing protocols in wireless sensor network design. This unit focuses on medium access control protocols and routing protocols specifically designed for wireless sensor networks. Unlike traditional wireless networks, sensor nodes are energy constraints, have limited computation capability and are usually deployed in large numbers. Therefore, conventional MAC and routing approaches cannot be directly applied. So this unit explains how communication is efficiently managed at the MAC layer and how data is routed from sensor nodes to the sink while minimizing energy consumption. MAC protocol fundamentals. The MAC, medium access control layer, is responsible for controlling access to the shared wireless medium. Since all sensor nodes communicate over the same channel, uncontrolled access leads to collision and energy waste. The primary goal of MAC protocol is in wireless sensor network is energy efficiency. Other important goals include low latency for timely data delivery, fairness, ensuring all nodes get access, scalability to support large networks. Major sources of energy wastage includes idle listening, in which the node stays awake without receiving any data. Collisions, retransmission consumes energies. Overhearing, which means receiving packets meant for others. Thus, MAC protocol aim to minimize these losses. Classes of MAC protocol. MAC protocol in wireless sensor network are broadly classified into fixed assignment protocol, demand assignment protocol, random access protocol. In which the fixed assignment protocol, each node is assigned a fixed time slot or channel, no collisions but low flexibility. In demand access protocols, resources allocated only when needed. It gives better efficiency but requires control overhead. In random access protocols, nodes content for the channel flexible but collisions may occur. Each classes represent a trade-off between energy efficiency, delay and complexity. So the next topic is low duty cycle and wake-up concepts. A key concept in wireless sensor network MAC design is the duty cycle. The duty cycle is defined as the ratio of active time to total time. Low duty cycle means nodes remain asleep most of the time. This significantly reduces energy consumption. Nodes follows a sleep-wake schedule where sleep period means the radio is turned off. Listen period means radio is turned on. A complete sleep plus listen period is called a wake-up cycle. Nodes can wake up using timers or long preambles sent by transmitters. In the cycled receiver approach, nodes spend most of their time in sleep mode, wake up periodically to check for incoming packets. If a sender wants to transmit, it sends a long preamble. The receiver wakes up during this sampling time and detects the preamble. This approach greatly reduces ideal listening, which is one of the major sources of energy waste. So next topic is contention-based protocol versus schedule-based protocols. MAC protocols can be classified as contention-based protocols and schedule-based protocols. Contention-based protocols, nodes compete for channel access and they are flexible and simple, but it has one disadvantage is that it has a higher collision probability. In schedule-based protocols, the nodes transmit in assigned time slots, collision-free communication, but requires synchronization and scheduling overhead. Therefore, there is a trade-off. In contention-based protocols, it is flexible, but energy waste is more. In schedule-based protocols, energy is efficiently used, but it's very complex. SMAC protocol. It is the short form of sensor MAC protocol. It is one of the earliest MAC protocols designed for wireless sensor network. Key features are nodes follow periodic sleep and listen schedules. Neighboring nodes synchronize schedules. It has three phases: sync phase, RTS phase, CTS phase. The sync phase nodes exchange schedules. In RTS, which means RTS is then short form of request to send, and CTS is uh, short form of clear to send. It gives an advantage of significant energy savings, and it's very simple in design. The disadvantage of this protocol is increased latency due to sleep cycles, fixed duty cycle not adaptive to traffic changes. Next protocol is BMAC protocol, which means Berkeley MAC, which is a highly flexible and simple protocol. Low power listening (LPL), in which the nodes periodically wake up and sample the channel. The transmitter sends a long preamble so that the receiver detects its detected during sampling. Advantages of using this protocol is it's very simple for implementation and adaptive duty cycle. Disadvantages is long preamble causes energy overhead and inefficient when traffic is high. The main goals of BMAC are simplicity, energy efficiency through low power listening, adaptability to different traffic conditions. BMAC avoids strict synchronization, making it suitable for dynamic sensor networks. The next one is mediation device protocol. The mediation device protocol is compatible with IEEE 802.15.4 low rate WPAN standards, in which nodes periodically sleep and wake up. Each node has its own sleep schedule. When a node wants to transmit, it must synchronize with the receiver. A mediation device (MD), which helps achieve synchronization dynamically, thus avoids keeping the transmitter awake continuously. Thus, it saves energy also. Next protocol is TRAMA, which is the short form of Traffic Adaptive MAC. It is a schedule-based MAC protocol. It consists of three components. First one is neighborhood protocol, which discovers neighbors. Second one is the schedule exchange protocol, which exchanges transmission schedules. Third one is adaptive election algorithm, which selects transmitters. Advantages of using this trauma is its collision-free communication. It's highly energy efficient. The disadvantage of this protocol is its complex scheduling and high overhead in dense networks. Then we move on to the routing protocols. Its requirements. Routing in wireless sensor network is challenging due to limited resources. Key requirements are energy efficiency, which maximize network lifetime, scalability, which supports large number of nodes, data aggregation, which reduces redundant transmission, fault tolerance, which handles node failures. Routing protocols must optimize communication while preserving energy. Routing protocol classifications. Routing protocols are mainly classified into four types: node-centric routing protocol, data-centric routing protocol, source-initiated routing protocol, destination-initiated routing protocol. Each approach focuses on how data is collected and forwarded rather than traditional address-based routing. First among the protocol is SPIN protocol, which is a short form of Sensor Protocol for Information Via Negotiation, which addresses problems of flooding. The key idea is in which the data is describing using metadata. Nodes negotiate before transmitting actual data. Three messages are commonly used: ADV, REQ, data. The ADV represents advertised data, request REQ represents request data, data to be transmitted. Advantages of using this SPIN protocol, which reduces redundant transmission and energy efficient. And disadvantages of the SPIN protocol is it does not give any guarantee that the data reaches the sink. So the example shows how data exchange ADV, REQ and the data messages. Only interested nodes request the data, preventing unnecessary transmissions. Next is directed diffusion. Directed diffusion is a data-centric routing protocol in which the sink broadcasts interested messages. Gradients are established, data flows the best path. Advantage of using this protocol is it is energy aware and robust to failures. Disadvantages, it is not suitable for continuous data streams. Cougar and acquire. Cougar treats the network as a distributed database. uses query-based data collection. Leader node processes queries, whereas in acquire it forwards queries actively through the network. Advantages are efficient querying and disadvantages is query overload. Next is one of the important protocol, which is the leech protocol, short form of low energy adaptive clustering hierarchy, which is a hierarchical routing protocol in which the nodes are grouped into clusters. Each cluster will have a cluster head, and this cluster heads aggregates data and sends it to the sink. It uses TDMA for intra-cluster communication and CDMA to avoid inter-cluster interference. The operation in this protocol is divided into two phases: setup phase and steady state phase. First, we will see about the setup phase. In the setup phase, nodes self-elect as cluster heads probabilistically. Cluster heads advise themselves. Nodes join nearest cluster head. Then the cluster head creates TDMA schedule. This phase determines the cluster structure. The next phase is steady state phase, in which the nodes transmit data in assigned TDMA slots. Cluster head aggregates the data and the cluster head sends the data to the sink. Energy is saved as nodes remain asleep when not transmitting. So advantages of using the leech is it reduces energy consumption, it gives data aggregation. Disadvantages of using this protocol is the random cluster head selection, and cluster heads may die early. Next protocol we are going to discuss is about Pegasus, short form of power efficient gathering in sensor information systems, which improves leech in a way by constructing the chains of nodes instead of clusters. That is, the node form a chain instead of clusters. Each node communicates with the nearest neighbors. Data is aggregated sequentially and sent to the sink via a chain leader. Advantages of using this Pegasus protocol is it gives 100 to 300% energy improvement over leech, low overhead, and disadvantages is it gives high delay and possible of data inaccuracy. So to summarize Unit 2, we focused on the design and operation of MAC and routing protocols in wireless sensor networks, where energy efficiency is the most critical design constraint. We began with MAC protocols, understanding their fundamental role in managing the shared wireless medium. We discussed how idle listening, collision, and overhearing are the major causes of energy loss, and how low duty cycle operation and low wake scheduling significantly reduce power consumption. Different MAC protocol classifications were studied, including contention-based protocol and schedule-based protocols. And protocols such as SMAC, BMAC, mediation device protocol, and TRAMA were analyzed, highlighting their working principle, advantages, and limitations with respect to energy efficiency, latency, and scalability. In the second part, we focused on routing protocols and their specific requirements in wireless sensor networks, such as scalability, fault tolerance, and data aggregation. Unlike traditional networks, routing in wireless sensor network is data-centric rather than address-centric. We studied important routing protocols, including SPIN, which uses data negotiation to reduce redundancy, then directed diffusion, which is interested-driven and energy-aware, Cogger and Acquire, which uses query-based data collection, Leech, a hierarchical clustering protocol that balances energy through cluster head rotation. Then we discussed about Pegasus, which improves leech by using chain-based data aggregation. So overall, this unit highlights that both MAC and routing protocol must be co-designed to maximize network lifetime, reduce energy consumption, and ensure reliable data delivery in wireless sensor networks. With this understanding, we can appreciate how protocol design at different layers directly impacts the performance and longevity of wireless sensor networks, which is essential for real-world applications such as environmental monitoring, healthcare, industrial automation, and smart systems. So to conclude this unit we covered MAC protocols focused on energy efficiency, routing protocols designed for large-scale sensor networks. So understanding these protocols is essential for designing long-lived and efficient wireless sensor networks. Thank you.